Hey, everybody. Welcome to a new edition of Keep Looking Up. My name is Kurt Spivey. I am the planetarium engineer at the YSU Ward Beecher Planetarium. With me this evening are our illustrious potentate, the planetarium director, Dr. Patrick Durrell.
Good evening,
And also our students who we couldn't live without, Eleni Hunsick
Hello.
and Nishan Adakari.
Hello.
So tonight we got a great show for you. We're going to do a topic that always gets good discussion going, and that is myths and misconceptions in astronomy. We have some biggies that we're going to tackle, but also we're going to, if you have any that you want to, when we discuss stuff, you want to bring up any in the comments, we will be happy to tackle those as well. So we hope you guys enjoy it. And I just need to move some stuff around here on my computer. So give me just a second. And before we do that, though, we are going to do our normal Star Talky stuff. And that is me this evening. Notice my face brightens up when I do that. I'm going to actually minimize that so I can be seen a little bit easier. And I am going to bring up that. And then I need to do this, and we are going to start with that Star Talk. So share screen, that, share, and then I have to do that. Okay, so here we are looking tonight. You'll see the time I have it set for is 1800 hours. That was 6 o'clock this evening that we're starting for, because of course we are now approaching the longest night of the year. We are coming up on the winter solstice. More on that in our next show on the 19th, by the way. But it does get dark now at 5 minutes before 5 o'clock. I am happy to report, though, we've reached the earliest times that the sun sets. It's going to stay at 4:54 for the next 3 or 4 days. Then our nights start getting shorter again on the evening side anyway. So this is the sky here in Youngstown at that time. And you'll notice I have us looking north here in the sky. Now, the problem is when you are outside at night, it's more like this. And unless you know what you're looking at, you're not going to be finding things all that easily in the nighttime sky. I am going to put those back on. Fortunately, the nighttime sky does give us a way to figure these things out. And what you want to look for is a very famous group of stars that's right down on the horizon here in the northern sky at 6 o'clock. We have 3 stars that make a handle, and there are 4 that make a cup. One of them is down here behind this tree. And for all my planetarium veterans out there, I'm sure you recognize that. That, of course, is the Big Dipper. And the Big Dipper is important for a couple of reasons. First off, when you are around light pollution, and I turned off the atmosphere. So this is what it looks like with light pollution. Actually, there's another switch down here I can hit. Sorry, I'm looking at notes as I do this too. So where is that? No, it's not that important. It's bright enough you can see it even when you're around light pollution. Let me just leave it at that. Second of all, this is as low as the Big Dipper ever gets in our sky. It's always going to be up in this part of the sky someplace. It never sets. And since it is always up there and so bright, we can use the Big Dipper to find the most important star in the sky. What we're going to do is we're going to take these 2 stars at the end of the Big Dipper's cup, and we're going to draw a line from the star at the bottom of the cup through the star at the top of the cup, follow that across the sky. When we do that, we're going to hit this fairly bright star right here. And that star is, of course, Polaris, also known as the North Star. And what makes it important, you'll see it is right over the end there. So if I actually move ahead in time a bit here, I think I can do it this way. Is it this one? Yep, that's too fast. Got to reset my time again. Sorry about that. Got to come over here, and there's 18. There we go. Very good. So Polaris is always at that spot in the sky. The whole sky appears to rotate around that one star while it stays put. Now, when the Big Dipper is this low in the sky, it can be difficult to find. It could be tucked behind a tree like you see here. It could be behind a building or a hill from your point of view. Fortunately, we do have a stand-in up above Polaris right here. We have a very distinct M or W shape in the nighttime sky. And I think I can get this the way I want it to. Yes. That, of course, is very distinct up there in the nighttime sky. And actually, I'm going to make those go away and do that, and then do that again. There, now it's the only one up there. This is Cassiopeia the Queen in the nighttime sky. And you'll see how this side of the W is more steep than this side. If you start with the star at the bottom and go through the one in the middle and curve just a little bit, that will also lead you right over to Polaris in the nighttime sky as well. So you can find that easily as well. Now, 6 o'clock is pretty early. That's the one advantage this time of the year. Even though it's cold outside, you can get out and explore a lot earlier than you would in the summertime when you're looking up there. So let's go due west first, because when you do that, we have 3 very bright stars. This one here is called Vega. This one up here is called Deneb, and this one is called Altair. And we find those 3 stars in 3 separate constellations. This is Lyra the Harp, this is Cygnus the Swan up here, and this is Aquila the Eagle over here. But if you connect those 3, they form what we refer to as the Summer Triangle, which is actually a lousy name because, as you see, we are in December and is still in the nighttime sky. But it's highest in the sky during the summer, and since it crosses nearly at the zenith, the very top of the sky, it is actually in our nighttime sky for something like 8 months out of the year. Very easy to pick out. That could be the first star pattern that you see in the nighttime sky tonight because of that, but it's not the brightest thing over here. If we continue on into the southwestern sky, you'll see 2 very bright planets. I was out walking on Thursday night, and I could see Jupiter here by 10 after 5. It was really bright in the nighttime sky. Saturn I could see by about 5:20 in the evening sky. And notice how close they are to one another in the nighttime sky. We are actually heading for what we call a conjunction that we are going to be talking about in our next Keep Looking Up. These guys are going to get closer together. Jupiter is moving this direction. Saturn is too, but at a much slower rate than Jupiter is. So we will be talking more about how close those 2 are going to be coming in the nighttime sky on December 19th with our next piece, our next Keep Looking Up, which is going to be cool. Also, there's a 3rd planet up there. This one is up in the southeastern sky. I could see this even before I could see Saturn. That's Mars in the nighttime sky. Very easy to pick out as well. It's not as bright as it was in September when we were on close approach, but it is still very bright in the sky, brighter than Saturn, and by far and away the brightest thing up in this part of the sky up here. Now there's another planet up here too. I think this little dot right there is it. That is the planet Uranus. Uranus they didn't figure out Uranus was a planet until the year 1787. A gentleman named William Herschel figured that out. And it does look like a very faint star up there. And when you're around light pollution, you're going to have no chance of seeing that unless you know exactly where to look for it. I've been at a dark location with a telescope that found it, and it didn't look much more than just another star to me, even in a telescope. So it's not much to look at in the nighttime sky. Okay, we're going to pull out just a little bit more. While we're up in this part of the sky, I said we have the Summer Triangle. It's right up here. Right near Mars is another very distinct pattern in the nighttime sky. Well, that's Andromeda the Queen right there. That's the daughter of Cassiopeia, who is right up here in the nighttime sky. But over here, we have Pegasus the Winged Horse up in the nighttime sky. And I'll zoom in on him a little bit. The Greek people really had active imaginations. They made him upside down. His head's here, his front legs are here. And this mess in here is supposed to be his wings. I don't know how they managed that out there, but that's what they figured out. If you shorten that up, though, you make another asterism in our nighttime sky. This is the Great Square of Autumn here, just above Mars in the nighttime sky. Not nearly as bright as our summer triangle, but still very distinct and almost directly overhead at 6 o'clock, or I should say almost due south at 6 o'clock. That gives you a little bit better perspective. I'll pull in just a smidge there like that so you can see that. So it is very easy to pick out. Now, also on December 19th, when we go to look at things, we are going to be going a little bit later into the evening. That's because there are two bright stars. This is the first star I saw outside on night on Thursday. That's the star Capella. It's in the constellation of Auriga, the charioteer, who they draw as a box. You can also draw him. Let me see here. I had this. There it is. A charioteer, and he's holding a goat. I don't know where they came up with that. Matter of fact, the name Capella actually means little she goat. So it might not have been an active imagination. It might have been something else that the Greeks were on when they created these things in the nighttime sky. I can't be 100% sure. But just down from there, there's a bright star right here. This one is called Aldebaran, and it is in another very famous constellation. That is Taurus the Bull up in the nighttime sky. And if I put the constellation lines out, you can see it a little bit better. His head is very distinct. His body isn't much to write home about. It's back here. But I do want to focus in on this little group of stars right here, which is called the Pleiades. This is an open cluster of stars that are all very young stars in the nighttime sky. When you look at it, you can see usually about 6. If you've got really good eyes, you may be able to see 7 there. But if you look at it with a telescope or a pair of binoculars, you can see how many more stars are in that section of sky. They all formed in this section of sky out of a cloud of gas and dust we call a nebula, and now they're gradually drifting apart from one another in the nighttime sky. Being young is a relative term. Those stars are still several million years old, but that's actually on the young side for a star. So those are a few things you can pick out in the nighttime sky. We do not have a link to it in our show yet, but if you do want to look at the nighttime sky, there is a great website you can go to. It is called skymaps.com. And on that website, you can get a PDF of the current nighttime sky, and it will show you not only this stuff, but lots of other things in the nighttime sky as well to go out and look up. It is a great time of the year to go out and look out despite the cold. Oh, something else that's up here. See this right here? That is actually a satellite. That is a NORAD satellite that just happens to be passing over at 1608. If you go out right after sunset, you can actually see a lot of satellites in the nighttime sky. That's because while it's dark down here on the ground, the sunlight is still bouncing off the satellites up above. The one you don't have to do that with so much is the International Space Station. It's so big, it's as bright as Jupiter over here. So you don't have to worry about seeing it. But ones like that little guy there, you can see right after sunset in the nighttime sky as well. So I am going to stop sharing the nighttime sky. And we are going to move on now and talk about our myths and misconceptions in the nighttime sky. So I'm going to bring Dr. Durrell on board here. We're both going to be talking about this one. And Eleni will be piping in as stuff comes up. And let me see here. I'm going to present. Okay, so that's there. I have to do this in a few phases. There we are. And I'm going to share screen again. And this time I'm going to share this one. Yeah. Yep. And then I am going to, I think I shared the right one. Nope, I went too fast. Back up one. Maximize. Then I should be able to do that. There we go. Okay, and the first myth or misconception that we're going to talk about has to do with the fact that there is a group of people who consider the fact that the moon landing was faked. They figured there was no way that NASA, in the time from the time John F. Kennedy first said we're going to go to the moon and the end of the 60s, that we could possibly land anybody on the moon. And they have all sorts of facts to point out the fact that it was actually filmed here on Earth and couldn't be done on the moon. Now, I will say, to start off with, a lot of people base this on special effects that we can now do in Hollywood movies. You couldn't do that back in 1969. Stanley Kubrick could, but nobody else could. And even he spent millions and millions of dollars on it. But you don't have to just rely on that. There are some easy ways to debunk the fact that we did actually go to the moon and land on it. First off, one thing that the pundits point to is that when the flags are set up on the moon, they appear to flutter in the wind as if the air conditioning is running in whatever sound studio they were filming this in. Well, there's a very good reason for that. The flags would have just hung limp, but as you look at this picture of the astronaut here, you can see there is this bar that they have in the top so the flag holds up in the nighttime sky and on the moon. Now, when they put it in the ground, they couldn't just stick it in the ground. It's really tough. So they actually had to take a hammer and pound the stake into the ground. And so they put energy into the pole. And Sir Isaac Newton taught us an object in motion tends to stay in motion unless acted on by an outside force. So after they pounded the stake into the ground, the stake had energy in it. The stake was wobbling. And since there is no atmosphere on the moon, the flag continued to wobble and appeared as if it was waving in the breeze. But really, all it was simple physics in action there. You'll pardon my my rather upset cat here. I'm going to put her down and get her out of the way. And another thing they pointed to was, if you look at the picture on the left, it doesn't appear the shadows line up correctly. They appear to be at perspective lines. And the picture on the right is what they point to. Because of the shadows, there must have been multiple light sources on the soundstage producing these uneven shadows. Thing you got to remember here, though, and we're going to talk about this a little bit later when we talk about another myth, but on the moon, the sun is up 14 straight days, basically, and it is below the horizon for 14 straight days. So a day on the moon is 14 days long, and a night on the moon is 14 days long. Because there is no atmosphere, if the astronauts had landed at high noon on the moon, the surface temperature would have been several hundred degrees and their suits could not protect them. Likewise, if they landed somewhere in the middle of the night on the moon, number one, it would be difficult for them to see what they were doing. But number two, it would be really, really, really cold, several hundred degrees below zero, which also isn't good for their suits as well. So all the moon missions were designed to land when the landing sites were near the terminator, where the light meets the dark, or right at dawn or dusk on the moon. So the sun is right down on the horizon, which provides these long shadows that you're looking at. But that gave them a moderate temperature that they could actually function in. The reason the shadows appear to be different widths and lengths only has to do with the fact that the terrain is not flat. It's rolling, there are craters, the shadows are going up and down and all around, all over things. It has nothing to do with the light source and everything to do with the landscape. All right. Another thing they point to is the lunar excursion module, or LEM, doesn't appear to have a crater carved out under it when it landed, even though it used its big engine to land on the planet. That also has to do with the fact that there is no air on the moon. The top of the moon is covered with a very fine granular dust, but not too far underneath that, just a little bit of the ways down, it's rock. So, because there was no atmosphere, it did pick up some of the lunar dust and blow it out to the side, but then the air didn't pick it up and swirl around like you see here on Earth. It just went out and dropped right down because there was no air to carry it anyplace else. So it didn't make a crater like we would see here on Earth because of that. And last but not least, one of the things they point to is every single picture that is taken of the moon, you don't see any stars. So if they were on a soundstage, they didn't have stars in the background. This has to be faked, right? Well, this is actually very easily to explain because remember I said the moon was just above the horizon off to the side. So there was a huge bright light source on the moon when they were there. This is very much like when you go to a football game and you're in a stadium and the lights are on in the stadium. Can you see stars outside in the stadium? No, because the lights are so bright in there, they're drowning out the light from the stars are there. They're there, but you can't see them in the nighttime sky. And these are just the major points that we talk about when we talk about the moon hoax. However, there are a bunch of others too. A great resource to debunk this is a gentleman that both Dr. Durrell and I really like. His name is Dr. Phil Plait. He's often called the bad astronomer because he has made a career out of debunking a lot of these myths. And he has a great in-depth look at how this works on the moon. He wrote a book called Bad Astronomy, but you can also go to his website. Just look up Bad Astronomy Phil Plait and you can find it, and you can find where he debunks the moon hoax too. But we were talking about how long the day and night is on the moon when I was talking about the shadows. So I'm going to turn it over to Dr. Durrell, who's going to talk to you about another thing that a lot of people talk about, and that is the dark side of the moon.
Yes, yes. And whenever I mention this to my students in my classes these days, fewer and fewer people know what I'm talking about when I say, have you heard of the dark side of the moon? Not enough people, but remembering Pink Floyd, obviously. But one of the things about the moon, and regardless of what phase you see the moon in, is we always see the same face, no matter where you are on the Earth. Okay, no matter where you live, when you look up at the sky, you see the same part of the moon. Sometimes you see half of it, sometimes you see a quarter of it, or a sliver, or the whole thing on a nice full moon. And that's what we see on the left, the near side of the moon. All right. Because this is the side that always faces the Earth. Now, the phases of the moon are caused by the fact that the sun lights up half of the moon. And how much of that lit up half of the moon we see standing on the Earth is what we see as the phases of the moon. So it all has to do with where the sun, the moon, and the Earth are. It has nothing to do with the shadows. Okay. Now, the thing is because of that, people say, well, there must be the other side of the moon must always be dark. Okay, so hence the famous term, the dark side of the moon, when that's not indeed the case. What's going on is the moon is tidally locked to the Earth. In other words, the moon actually, as it orbits the Earth, very slowly rotates so that it keeps pointing that same part towards us. Okay, it's like if you're dancing with somebody and you move around and you're still facing that person. The moon does spin around, but it spins around once every time the moon completes an orbit in about 4 weeks. So as a result, it's not always the near side of the moon that's lit up. Sometimes the part of the moon that you can't see at all, which we call the far side of the moon, is also lit up. And as Kurt mentioned, for any spot on the moon, any location, whether it's the Apollo 11 landing site or any of the famous craters, they see half of the orbit, the sun is up in the sky. So really, there is no truly dark side of the moon. There are some craters at the very North Pole and the very South Pole of the moon that are deep enough that the sun never, ever comes above the horizon. But that's not quite the same thing. So what we have when we see the moon is the near side that we're all used to seeing. And if you've got a small telescope, by all means, have a look at it, because, you know, as good as the pictures that we can show you of the moon, it doesn't beat seeing it for yourself. And then the other side that we never see from the Earth is called the far side of the moon. And it's simply that part that we don't see. The only people who've seen it live are the Apollo astronauts as they orbited the moon, and pictures that we've had from numerous space probes. Actually, we can go back to that previous slide. You can actually see that we actually got the good part of the deal when it comes to the moon, because as you can see, the far side of the moon, the picture on the right, that's the part we can't see. And I don't know what other people think, but I think the one on the left looks a little more, you know, a little more happening.
I should point out that because the same face faces the Earth all the time, the reason this is the case is that far side has been getting bombarded by a lot more junk than the side that's facing us.
Yeah, but also the crust is thicker on that side too. And there's lots of mysteries of the moon we're still trying to solve. I mean, we don't, you know, even this many years after the Apollo landings, there's still lots of things we don't understand about the moon, and we're still learning about it. And that's one of the fun things about astronomy. So yeah, so even there, the moon is a fascinating place, but yes, we did land on it, most certainly.
Very good. Okay, so now we're going to move on to another granddaddy of all beliefs out there. A lot of people, and it's really, really disappointing to us astronomers, have fallen back on the notion that the Earth is actually flat. Actually, this Flat Earth Society, believe it or not, started back in the 1800s. And it was a backlash to all the scientific progress that was being made at the time. And really, that's kind of what's going on now, too. It's kind of a backlash against what we're talking about when it comes to science these days. So, from what I understand, I am not one of these people. I've not gone to their meetings, but from what I understand, the flat earthers believe that the Earth is centered at the North Pole. That's at the center of the flat part. And there is an ice wall boundary all around at Antarctica. And the sun and the moon are 50 kilometers in diameter, and they circle 5,500 kilometers above the Earth. And then all the stars are on a flat dome behind that is rotating as well. And they have all sorts of things that they say prove this is this way. One thing I did not put in here is the image I had on our notation for the show. It's the NASA logo, but instead of saying NASA, it says "Not flat, we checked." That's always an important thing as well. There are several ways that we figured this out, and actually, I'll have Pat talk about this one and the next one.
Yeah. Well, first of all, one of the, there's lots of misconceptions that are simply based on, people haven't heard about it or may think of something a little different. But some of the worst myths are the ones where, just like the moon hoax that Kurt described, which is really people not thinking that ancient people in previous cultures and civilizations could figure things out like we can figure them out. And that's a real danger. And it's always problematic, for those of us in the business, about the flat Earth, because this is something that has been known for a very, very long time. Matter of fact, we can go over 2 millennia ago. People didn't have computers, people didn't have telescopes, but they were very good sky watchers. They were very adept at looking at the sky. And some of the Greeks were very good at trying to understand what the night sky was. And one thing people were very familiar with was lunar eclipses. which is caused by the Earth's shadow. And as a matter of fact, Aristotle himself and others noticed that during a lunar eclipse, when the moon passes behind the Earth's shadow, the shadow is always round. Okay? And this little time lapse, yeah, here's a picture of a lunar eclipse, not at totality. This is when, as the moon is moving into the Earth's shadow, and you can see that the shadow is curved. That's actually not a phase of the moon. It's curved the wrong way. And that shows you the only way you can get a circular shadow is something that is shaped like a sphere. So this is one of those things, so people understood 2,400 years ago. Okay, here's a full look at the Earth's shadow in this sequence of images of a lunar eclipse. Okay, so this is something people began to understand through basic observation and critical thinking 2,400 years ago. But the Greeks didn't stop there. Okay, a very famous experiment was done. Well, maybe not an experiment in the sense that you think of it today, but a couple hundred years later, Eratosthenes, who lived near Alexandria in Egypt, noticed that on a certain day of the year, which would be the first day of summer, the summer solstice to us now, the sun would be very high in the sky and would shine directly down a deep well in Syene, in southern Egypt. Okay, and that meant the sun was straight overhead. I mean, otherwise you wouldn't see light going all the way down to the bottom of the well. Well, on the same day, okay, it was recorded that further up in Alexandria, if you had a stick staying straight up in the ground, it casts a shadow. And the only way you can cast a shadow is if the sun is not directly overhead, but a little bit off. But not only did they think about this just pure geometry, they were able to measure that angle. And what Eratosthenes did was figured out, well, if the sun is directly overhead in one spot, but not directly overhead in the other, means the Earth isn't flat at all. But he even went a step further. He said, well, if I know the distance between these two locations, and the angle that the sun was not overhead, okay, and it's about 7 degrees. So this is something that one could measure with a stick, in the afternoon here today, he was actually able to calculate the circumference of the Earth. And now the units they used back then were a little complicated, something called the stadium, which people still disagree on what one stadia was. But based on one of the most common interpretations of that unit, meant that not only was the Earth round, but Eratosthenes figured out the Earth was about 40,000 kilometers or so, which is pretty close to the right answer. And again, this is, many, like I said, 2 millennia before the space probes went up. Okay, so people had this figured out, like I said, the size of the Earth, 2,260 years ago. So that's why it's baffling to scientists. We don't like being baffled, but it's baffling to scientists when we see this and go, this was figured out 2,400 years ago, quite convincingly through nothing but geometry. Like I said, no fancy calculus, that hadn't been invented yet, no telescopes, no computers, just a critical look at the sky and basic geometry. So we've known about this for a while, and there are many things since then in history that have gone to show this even more.
Before we move on to that, though, I want to point out that our other astronomer we have at YSU, Dr. Feldmeyer, when he gets confronted with this, he says this is the cheapest way you can prove the Earth is round. You get 2 people in one car and 2 sticks that are exactly the same length and a couple of tape measures. And then you have one person flips, one person gets in the car, one person stays where they are. The person with the car drives, say, from Youngstown down to Wheeling or someplace like that, maybe 100 miles or so. Then you get on your cell phone, you put your stick on the ground and say, okay, measure the shadow. And you measure the shadows at the same time. You see the difference in the shadows, then you can do this geometry and prove the Earth is round. 2 people can do that, no problem. So I do know some more famous people that claim the Earth is flat, and they can actually buy a weather balloon and send a GoPro camera up and do it too. But anyway, there are a number of things that can help us also figure out that the Earth is round. For any of you who've been down to COSI in Columbus, this is what's known as a focal pendulum. It has a really, really long string, and once you get the pendulum swinging, it stays swinging in the same plane, even though it's attached way up above. Uh, we go back to Sir Isaac Newton, an object in motion tends to stay in motion unless acted on by an outside force. So it's just going to continue to swing in this one plane. And then the Earth rotates beneath the pendulum. And this next image will help you see this better. This is a different one, not the one at COSI. Many science museums have these. But as the Earth rotates beneath it, the pendulum knocks over these little pegs on either side as the day goes on. And then some poor schlup like I had to when I worked at COSI has to go back and put the pegs back up at the end of the day. But it does show the Earth rotating underneath the pendulum. Something else that shows that the Earth is round is something we call Coriolis Force. When you watch the weathermen and they always say the wind's coming out of the south or the wind's coming out of the north, if the Earth was not rotating and it was flat, the wind would go straight from west to east. That's why they're called the prevailing westerlies. But around a low pressure, the wind spins counterclockwise, and around a high pressure, no, I got that backwards. Around a low pressure, it spins clockwise, and around a high pressure, it spins counterclockwise, and that is due to the Coriolis force. This image is showing, if you look at the camera fired northward from the equator, if the Earth wasn't turning, the cannonball would go straight up. You have to have a really strong camera to shoot it, cannon to shoot it the several thousand miles it's showing in this picture. But because the Earth is turning, the cannonball actually curves off, and that's called the Coriolis force. We actually have something called Hadley cells. There are 6 different zones where the wind reverses due to this rotation. And when you look at Jupiter, the reason it has all the stripes, it's spinning so fast, it has lots of these zones on board as well. So the Coriolis force also shows that the Earth is a sphere. Another one, if the Earth was flat and a ship is sailing away from you, it would just continue to sail away until it becomes a dot on the horizon and beyond your view. But that's not what happens. Ships appear to disappear over the horizon, and that's because of a curve. In this particular picture here, the ship on the left, apparently called the Global Success 1, is 4.9 nautical miles from the person who took this picture. And the other ship, which I believe is pronounced the Eagle Kinabalu, is 10.2 nautical miles away from the observer, and you can't see the hull of the ship. It's down below the waterline. You can see the tower, but that's due to the curvature of the Earth. This is also true is if you had an observer on the ground here. Well, let's say you're in downtown Youngstown. You have an observer who's standing at the base of the Home Savings, now Premier Bank building, and you have another observer who's standing on top of the Premier Bank building. For the person on the ground, the sun goes below the horizon. The person who's on top can still see the sun because it's going down behind the curvature of the Earth. So there are a number of ways that you can determine this. The sticks and shadows method is the easiest for anybody. But if you have a little money, you can get a weather balloon and a GoPro camera. Weather balloons go up to the stratosphere, and you can actually see the curvature of the Earth that way too. Okay, we are going to move on to our third myth now. And this is one I talk about all the time. And that is what causes the seasons here on Earth. And this is really just a misconception. This is not anybody trying to be malicious like we have with the we didn't land on the moon or the Earth is flat myths that we just talked about. We're going to talk about why we have seasons. And a lot of people, when they learned about the seasons, they know it's colder in the winter, warmer in the summer. So they think that during the winter, we are actually further away from the sun than we are when we are in the summer. And the reason for that is a lot of people learn the seasons by looking at graphics like this. And what this is, the author has attempted to do, the artist has attempted to do, is kind of show the uh, image from a perspective. We're not looking at it from straight overhead. If you were to do that, though, you would discover our Earth's orbit is almost perfectly circular. It's just a tiny bit egg-shaped when we look at the seasons. Actually, believe it or not, on January 2nd, we are going to be at our closest approach to the sun. We average 93 million miles away from the sun. We aren't always 93 million miles of the sun because we're a little egg-shaped. On January 2nd, we are actually going to be 91.5 million miles from the sun. And then on July 4th, we are the furthest away from the sun. We are 94.5 million miles away from the sun. So our orbit changes by about 1.5% over that thing, because we're talking about 1.5 over 93, so it's a very small fraction of a percentage. So what actually does cause the seasons? That goes to the tilt of the Earth. We don't go around the sun straight up and down. We are tipped over 23.5 degrees. You'll notice in each of these pictures, the little purple line there is our tip on the Earth. And you'll notice all these tips are pointed the same direction. All of those point at Polaris. We'll get back to that in just a minute. So what really causes the seasons isn't how far we are from the sun, but where the sun is in our sky. So right now, while it's wintertime here, if you were in the southern hemisphere, like over here on this picture, you're actually tipped toward the sun. Right now in the southern hemisphere, they're getting 16, 18 hours of daylight like we get in the summer. Right now, we're only getting about 8 hours of daylight. So the sun's not up for as long. Thus, it does not have as long to heat up the ground and everything. So it cools off. Now, this doesn't happen immediately because this also has to do with the ice at the poles and stuff. We're approaching the shortest day of the year, but we don't hit our coldest weather until January, February. That's because the ice at the poles has to affect things, and then that starts affecting the air masses as well. One other thing affects it, though, too. In the summertime, when the sun is high overhead, you can kind of picture this with a flashlight, too. The sun is coming right down, and the light is concentrated in a small area. So the light is more intense when you're looking at that. As you're driving around this time of the year, even if it's the middle of the day, have you noticed wherever you're driving, the sun's right in your eyes, you can't get it out? The sun's at a more oblique angle. It's much more down. So this beam over here is the same amount of light as in this beam here, but it's spread over a much wider area. So same amount of light spread over a much wider area. That means less energy per area is hitting. So we're not getting as much energy from the sun, in addition to the fact that it isn't up for long. And those are the two things that actually cause our seasons when we look at it. So it's a common misconception, but distance doesn't have anything to do with it. It's all about the tilt of the Earth. And remember that we are tilted pointing toward the star Polaris. So with that, I will turn you back over to Dr. Durrell.
Yes. Yes, I didn't know if Lainey wanted to join in as well.
Oh, yes, Lainey, please.
And of course, are there any questions so far? We've talked about a couple of the more outstanding myths, but
I'm not seeing any questions.
Yeah, everybody liked Merope's appearance, though, apparently.
Oh, yeah, sure, okay. Yeah. Well, one of the things that we always show in our shows, whether I show it in my class or Kurt Nishon or Elaine show in the planetarium shows, is, of course, we always like to point out the North Star. It's probably the most famous star in the night sky. But one of the great misconceptions is that, of course, we always talk about the North Star, But one of the misconceptions is that Polaris is also the brightest star in the nighttime sky. And this one is actually, it's not even a case of debunking it. It's a very common thing, but it's not. It's not, as a matter of fact, it's not even close. The only reason the North Star kind of stands out, like when Kurt showed you earlier in the star presentation, is because it's an average brightness star, but there's not a lot of stuff around it, so it's kind of easy to pick out. This is a picture of the 25 brightest stars in the night sky, and Polaris isn't one of them. Matter of fact, if we're counting down the hits as far as brightnesses of stars, Polaris doesn't even crack the top 40. Okay, and no, I can't do Casey Kasem. Polaris is actually a variable star. It actually changes its brightness just a little bit, by about 10 or 15%. So its actual position on the brightest star hit parade changes, but it's always in the 40s. Sometimes it's in the low 40s, sometimes it's in the high 40s. But again, there are at least 40 stars brighter than it. So why is the North Star so important? Well, you know what people say: location, location, location.
All right. So we'll move on to the next one here. And these are some quick hitters we're going to go with here now. And one of them is when you see, especially movies like The Empire Strikes Back and things like that, when we talk about the asteroid belt surrounding the sun, the myth is that objects in the asteroid belt are very close together.
Yeah, this is always an interesting one. And by the way, this is something that happens even in programs, more scientific, shall we say, than The Empire Strikes Back. We always see these kinds of depictions of asteroids as being these lumps of rock that are really close together, and that flying through an asteroid belt is a really bad idea. Okay, this image is just an example. This is an artist's rendition of an asteroid belt. It doesn't sound like a very nice place to try and go through, whether you're flying a super star destroyer or not. However, in reality, at least the asteroid belt that we have is located between the orbits of Mars and Jupiter. There's a big gap between those two planets. And in between are many, many hundreds of thousands, over 1 million cataloged asteroids and countless smaller ones that haven't been cataloged. So if you give those numbers, people say, well, that's a lot of asteroids. But what's often not embodied in these shows, like I said, even some of the more science-oriented ones, is that there's the space in the asteroid belt is still big. Okay, space is big. Take it from me. So the space between asteroids is actually huge. If you were standing on an asteroid in the asteroid belt, clinging on with the little tiny gravity that each asteroid has, you would have a hard time seeing the next asteroid with your naked eye. Okay, so they're actually quite far apart. We have sent multiple space probes through the asteroid belt, because you have to go through the asteroid belt if you want to visit Jupiter, Saturn, Uranus, Neptune, and Pluto, for all of our Pluto fans out there, and places beyond. Never been a problem. Okay, you can't fly like the Millennium Falcon, dipsy doodling around asteroids, with our own space probes. They go through no problem. So you see these kinds of diagrams that they look kind of cool, but certainly in our solar system, it's not really that densely populated.
Yeah, correct me if I'm wrong here, Pat. We believe that the asteroid belt would have been another rocky planet like Mercury, Venus, Earth, or Mars. However, the gravity of Jupiter kept all this material from forming together into a lump. But if it had, it would have been a rocky planet smaller than Mars.
Oh, it would have actually, it wouldn't even be close to that big. People, it's the asteroid belt is not the result of a planet that got destroyed by half the Starfleet. It's basically basically it's a lot of the leftover pieces that never became part of Mercury, Venus, Earth, Mars, Jupiter, and Saturn. Okay, these are the leftover pieces. Like if you see a new house getting built, and before they clean everything up, there's like pieces of, stuff all over the place. Well, that's kind of what the asteroids are. If you took today's asteroids and put them all together, like putting a big thing of soap together or something, it would be a lot smaller than our moon. So it wouldn't be very big. But that's why we study asteroids, because they're the leftover pieces when the solar system formed a long time ago.
And may I point out that we just had a mission, OSIRIS-REx, that visited one of these asteroids, Bennu, and is bringing material from these asteroids back to Earth in 2023.
And Hayabusa 2
Hayabusa
touched down
2.
earlier today. Hayabusa 2, the Japanese mission that has a little bit of asteroid stuff, landed in Australia just a few hours ago. So you're going to be hearing more about that in the news.
Current
the capsule came down, and I believe they picked it up and everything. That was around 1 or 2 o'clock this afternoon. So
wow, I didn't hear about that. That's awesome.
Yep. Asteroids, bringing asteroids home to you.
Yes. And was it the European Space Agency that had the mission that orbited Ceres?
No, that was the U.S. That was the Dawn spacecraft.
That was NASA? Okay. Yeah.
That was NASA. That was Dawn.
The largest of the asteroids to Ceres, which if you want to call a protoplanet, Ceres is as close as you got out there. So
asteroids are neat things. They're not just these little cinders and things that get in the way of your spacecraft. They're truly interesting objects for a variety of reasons.
All right. Very good. Let's move on to our next myth. And that would be that you can actually land on the surface of Jupiter or Saturn. And this one is a little bit different. The gas giant planets are different animals than the terrestrial planets. All 4 of the terrestrial planets, Mercury, Venus, Earth, and Mars, have a solid surface. So technically you could land on the surface of Venus, but you get crushed like a grape in like 2 seconds if you did that. The other ones, we've landed stuff on Mars. We could land something on Mercury. We haven't yet. And of course, you're on Earth right now. The gas giant planets are different animals altogether. It is possible that there is a solid core down in the center of the planets. As a matter of fact, they have so much gravity, it's likely that there is. But they are also made almost entirely of hydrogen gas. So there is no true surface. If you go through those clouds, you just keep going down, and the pressure gets stronger and stronger. And eventually the pressure gets so strong, especially at the center of Jupiter, that you might have a core of metallic hydrogen under there. But you'd never reach that as a space traveler because the pressure would just be too high. Saturn's an interesting one too. It's made mostly of hydrogen too. Both of these have some other elements in the clouds as well, which gives them their distinct colors. But if you had a bathtub big enough, Saturn is less dense than water. If you had a bathtub big enough and tried to give Saturn a bath, it'd float. So there is no solid surface under any of these gas giants. Now, Pat, if you'd talk a little bit about Uranus and Neptune and the differences between those two and these two.
Yeah, well, there's a little more ice involved with Uranus and Neptune, and sometimes they're actually called ice giants as opposed to gas giants. But it's still the same basic idea. I mean, a probe was dropped into Jupiter's atmosphere almost 30 years ago from the Galileo space probe. And it went in to study, wind patterns and all sorts of things, but it didn't get very far into Jupiter before the conditions were just too much for it. And that's going to be true for any of these objects. So yeah, you can't land on Jupiter, on Saturn. If you want to go and visit those places and have a resting stop, go to one of their rocky or icy moons. Be a little more hospitable.
Really cool in and of themselves. All right. Next up, we're going to talk about one of Pat's favorite things. And you can be very brief with this, Pat. So we're going to talk about Nibiru.
This one hasn't been around for about the last 8 years, but it's one of those, again, this is another one of those things that, one of the things we always talk about when we talk about astronomy is the scientific method and the ability to, make observations about what's going on. And, this one goes back about 45 years when it was claimed from Sumerian tablets, a misreading of Sumerian tablets, that there was this mythical planet called Nibiru, supposed to be the 12th planet. And by the way, we don't know what 10 and 11 are. That has this very elliptical orbit around the solar system and populated by beings. And it's something to do with, early civilizations. I don't even know all the details. It was very popular stuff in the 70s. And the idea was reborn in 2012, if you all remember the Mayan calendar stuff. And just this idea that there's this massive planet that comes into the inner solar system every 3,600 years or whatever the time is. I mean, these are the kinds of claims that people make, and you go, and just quickly go, no, this doesn't make, yeah, exactly. This makes no sense whatsoever. If that happened, the planets of the orbital planets would have been disrupted a few thousand, long, long, long ago. And people claimed, well, it's coming right in. It'll be here in December 2012. No, it wasn't. We would have seen it. We're astronomers. We're not that bad at our job. So, I just point this, there's a lot of these sort of, statements that people make. One was the Earth axis is tilted over an additional, 40 degrees or something. And these are claims that are very easily debunked. And it's just a case of going, no, and so this, I just threw the Nibiru one is just one of many examples of things: spacecraft following comets, Planet X coming to destroy us. There's all sorts of these ridiculous things that people will say, and then we go and say, if what you're talking about is real, it would have been seen a long time ago, or people would have noticed. And I don't mean just astronomers; I mean other people would have noticed. And it's kind of frustrating because it's like things that you have to remember, the burden of proof is on the people who make the statement. Okay, so that's one of the things that
with current events too, I might add. So
yeah. So
we're not going to get into that.
Nope.
But I do want to point out that Nishan did put in our comments on Facebook a link to skymaps.com. So if you do want your own copy of the night sky chart to go out and look up at the stars, be sure to pick that up. Eleni, were there any other quick hitter myths that you wanted to touch on before we wrap it up here tonight?
I think you guys touched on everything that could be addressed quickly.
I
don't want to add like 10 more minutes.
Now, we as astronomers tend to explain things very thoroughly as we go through here. There are a lot of little misconceptions and things like that too. If there's something that's been bugging you about that, just comment on this. We'll get back to them and answer the comments. We're happy to do that. We hope you guys will practice good science and you will go out and take a look up at the nighttime sky. And even though it's a little cold at this time of the year, I think we are supposed to get some clear nights in a few days or so. And next time, our final Keep Looking Up of 2020 is going to take place 2 weeks from today on December 19th. It is going to be our last one for a little while. We take off in January while the new semester is getting started up, and then we'll start up around February again. But this one is going to be about the winter solstice, and we'll talk a little more in depth. We talked about the seasons in this one and the myths behind it. We're going to be talking more in depth about the winter solstice and the Great Planet Conjunction. I mentioned it in the Star Talk, Jupiter and Saturn. They're close now. It's going to get a lot better over the next couple of weeks. So we hope you will join us for that. That, once again, is going to be Saturday, December 19th at 8 p.m. So until then, you guys are a great audience. Thank you for doing these with us. We can't wait to get you guys back in the planetarium. It's still going to be a little while, but we can't wait to get you guys back in the planetarium. So until the 19th, everybody, keep looking up.